Hello, and thank you for watching today's session on AI-driven DevOps CI/CD pipeline. This video was prepared by Francesco and myself. We're both part of an Accenture group of highly motivated SREs specialized in the state-of-the-art SRE DevOps practices with the goal to promote a growth mindset that embraces agility, DevOps, and SRE as the new normal. I myself have a background in software engineering, AI, and industrial automation. I specialize in several SRE-related topics such as AIOps, observability, and chaos engineering.
Thank you very much, Michele. Welcome, everybody. I'm Francesco Sbaraglia, and I'm based in Germany. I'm working as SRE and IOPS Tech Lead EMEA at Accenture. I have over 20 years of experience solving production problems in corporate, startup, and government. Furthermore, I have deep experience in automation, observability, multi-cloud, and chaos engineering. I'm currently growing the SRE DevOps capability at Accenture. Let's have a look at the agenda for today. First, we will have a look at the why we need to monitor and observe a CI/CD delivery pipeline. Then we will have a look at the classic continuous delivery pipeline architecture. We will refresh about observability and how to use OpenTelemetry in this case. Then we move to the AI-driven approach. We will explain what we are doing and how we are using AI. We will have a demo, and Michele will go with the conclusion and takeaways. Let's move now on the first point. Why to monitor a CI/CD pipeline and platform? You can imagine the CI/CD platform is really critical. Let's see our key challenges. SRE and DevOps needs a CI/CD platform that needs to be reliable and with predictable failures. SRE and DevOps needs a data-driven approach to run proactive capacity management. When and how to increase resources. SRE and DevOps needs a CI/CD to deploy hotfix and bugfix during outages. Now you can imagine how a CI/CD platform became really critical. Most of the time, the CI/CD platform is black box. So we want to understand what is happening inside, how we can improve all processes, and also how we can improve each steps of the CI/CD pipeline.
Thanks, Francesco. Now that we introduced the key motivation for today's talk, I suggest we dive into the first major topic, which is CI/CD. What we see here is the architecture of our CI/CD flow integrated with the observability platform. So let's start from the top left. Imagine a DevOps engineer who's writing some new code, and when he's done, he commits it to the Git repository. Subsequently, this commit will trigger our CI/CD pipeline. As you can see, we are using Jenkins that after the commit will auto-initialize the pipeline. Specifically, Jenkins will initialize the dynamic agent pod, which we also see here, and which is dependent on the resources that Jenkins takes from the Kubernetes cluster. In the next step, the changes will be deployed to the production environment, ultimately reaching our end users. So far, everything I've talked about is pretty much standard, I would say. But what we're really interested in is how we integrated the pipeline with our observability platform. In the upcoming slides, we will explain more about the observability platform and how we're using the OpenTelemetry standard to collect data from our Jenkins pipeline. But right now, what we're interested in are the KPIs that we see on the right-hand side that we want to derive from the data that we're collecting with OpenTelemetry. So I suggest we analyze one by one. Let's start with the first one, which is speed of the CD pipeline. I want to stress the CD part here as we're only talking about the deployment. Now, consider the situation in which an outage occurs and the DevOps engineer needs to deploy a hotfix as soon as possible. We are talking about a critical situation because the system is unstable and the end user is expecting a fix. Otherwise, there's a risk that they might abandon it, and that's something we want to avoid. So as you can see, by measuring the deployment speed, we also improve our mean time to recovery. The quicker I manage to deploy the hotfix, the lower will my MTTR be. The next KPI that we're deriving is build test success rate. This one gives us an indication on how many core tests or unit tests are successfully completed once deployed to production. Furthermore, we also want to count the total amount of deployments we have each month per pipeline and possibly per application. We want to know the lead time for a change or a deployment. This one is relevant for identifying the time between the moment in which the DevOps engineer executed a commit to when the deployment actually took place. Furthermore, we're also measuring the change success rate, which corresponds to the total number of successful deployment divided by total. Speaking of which, some of these might fail, which is why we want to identify the success rate. And the last one we see in this slide is the availability of our CI/CD platform, which is obviously a critical KPI. Now, coming back to the big picture of this architecture, you see the benefit of collecting this kind of data and feeding it into the observability platform is that the DevOps engineer who does the deployment doesn't even need to use Jenkins to monitor the state of his deployment, since all of this data will be readily processed and available in the observability platform. So it's there where our DevOps engineer will go and check the status. Okay, speaking of observability. To introduce this concept, observability is the measure of how well internal states of a system can be inferred from knowledge of its external outputs. This basically translates to understanding how the various components in our systems are connected to each other, and we pose questions such as, what are these dependencies? What are their dependencies? How do they work together? So in other words, we are introducing transparency and visibility across our entire end-to-end system. Why? Because our ultimate goal is to derive actionable insights from it. Here are a couple of notions relevant for observability. We have different sources of data illustrated in the center figures that we need to observe. As we mentioned, observability is the ability to measure a system current state based on the data that it generates, such as logs, metrics, and traces, the so-called golden triangle of observability on the left-hand side, while on the right-hand side, we see the golden signals, which consist of latency, traffic, errors, and saturation. Okay, before we move on to the AI side of things, it's also really important to understand how we collect all of this data that we just mentioned. We are using OpenTelemetry, which is an open source standard for generating and capturing what we see here, traces, metrics, logs. So basically our golden triangle. On the right-hand side, you see a diagram illustrating how exactly OpenTelemetry works. So I suggest we quickly analyze it. Let's start from the top, where logs, traces, and metrics are generated, in our specific case by the pod and the container. But from the diagram, we see that we're talking about raw data too. In the middle, we have the OpenTelemetry collector, which enriches and processes all of this data. Specifically, this enrichment process occurs in a completely uniform manner for all three signals. Basically, the collector guarantees that the signals have exactly the same attribute names and values describing the Kubernetes pod that they come from. So what happens in our case is that the exporter takes all of this data from Jenkins. So we're talking about system logs, app logs, traces, metrics, etc. It correlates all of it and it forwards it to our backend. So the key benefit from this approach, from this dynamic approach, is that we don't have to install anything on each single Jenkins agent. Instead, we simply attach OpenTelemetry to the Jenkins master, and this ensures that we receive all three signals with only one agent.
Thank you very much, Michele. Now let's have a look on the AI-driven approach. What you can see here, we have three different stages: observe, engage, and act. In observe, we are using OpenTelemetry collector agent to collect all the inside logs, metrics, and traces from the CI/CD pipeline, but also from the underlying platform. On the engage, we are going to run a machine learning prediction. So we are going to try to understand and correlate if there are disruption. You see here that we have two different KPIs. The first one is the CI/CD reliability. The second one is CI/CD pipeline end-to-end. So we are running a smoke test every 15 minutes and test all stages of a fake pipeline. Then we move on the correlation and prediction. Correlation and prediction will try to understand if there will be a disruption and to predict the service healthiness of the next half an hour. Then this will land on predictive alerting. So we are sending an alert before something will happen, or in zero-touch operation or zero-touch automation. In this case, we will have a self-healing or scripts will run automatically to fix the CI/CD pipeline and platform. In this case, we can also increase the performance. We can increase the resources that we have in our CI/CD platform to prevent any disruption that can happen. Okay, this is a funny slide. What we did is to try to understand if our SLAI they are correct. We asked ChatGPT. We asked ChatGPT if they can give to us a couple of SLAI. And you can see here what we selected at the end. So the first one is about the build success rate. Really interesting because it's also the one that we are using. Then we have a build lead time. You can imagine which kind of measure we have here, and it's really important for our SRE and DevOps. Tech success rate, we have deployment success rate, deployment lead time, really interesting one because it's the one also that we are having in our prediction, and machine learning will run and will try to understand if there are correlation with the other event. And then what we are using here is also change failure rate. But we will see this running automatically in the next part because we will see in a demo. Now let's move on. Our demo will have a two part. The first part, I will explain what we are doing with observability and using OpenTelemetry in a Jenkins pipeline, which kind of insight we will get, and then try to understand how to use them for the machine learning part. And then the second part of the demo, Michele will explain us what we can do with AI. Okay, let's start first to have a look on our pipeline. As you can see here, we have our smoke test pipeline. It will run every 15 minutes. You see the running over every 15 minutes, and it's covering all stages. Here is everything green. Let's have a look on something that is broken at the end. So we have one time that was broken. We click inside. We have a look on our observability. As I mentioned, we are using OpenTelemetry. We are getting this completely dynamic. And let's have a look on the inside. Those are collected everything automatically. This is a trace. So the first stage of our pipeline, we see the name of the pipeline and we see the time that was running. It's around 1.4 minutes. We can also click on the span and we can have a look all stages, which kind of progression they had and when stopped. On the waterfall is really interesting because you see from the start, the first stage will be about the agent. So we are running Jenkins on inside our Kubernetes cluster. You can imagine that every time that the agent will start, it will be allocated a new pod. And this new pod will contain the Jenkins agent. Jenkins agent, of course, will do something as first, it's the allocation. So we request resources to Kubernetes and start a new pod. Of course, you can imagine here that if we have a problem with our Kubernetes cluster, if the Kubernetes cluster is saturated, then this will take longer. So here we can already have a look. We can jump inside and we can try to understand if there are problems in this case. Then we see a checkout. So there will be the download of our Jenkins file. So our Jenkins file is the description of all steps. We see here that is getting downloaded, is consuming around 16 seconds. So we can do already some improvement. Then the script will deploy and compile our YAML file. So it's the one that we want to kind of deploy to our Kubernetes cluster in prod. It's taking 47 seconds. And here you can see the deep dive in all stages. We can click inside and also understand what is going on. Then there is a build of a new version. We are building a new version for production. They will contain like our source code. And in this case, we are going to have a build at the end. Then we place the gate. Because SRE, we want to understand if we already have a problem in production, we already consumed our error budget, and we don't have any more, here we have a block. So this is the case. So in this case, we cannot deploy to production because our error budget was already consumed. Another interesting part is about the performance summary, what you can see on the right side. So we see here that the whole time that is required to run this pipeline, there is only one imputation, is about application. So imagine that we have a database, so we had other different third-party software that we needed to collect. Here you would have seen something like network, compute, and database. We can jump now on the graphical overview. What you can see here from the Jenkins pipeline, using the OpenTelemetry, we are also getting some of the interesting metrics out of the box. The first one is about the request rate. It's really important for SRE because we wanted to understand when there is a peak on the request and if it will happen maybe as slowness. And if also we need to kind of run and increase some resources, this will be also the case. Second part about the request latency. So this will tell us which kind of problem we have on this Jenkins master. And what we can see down is also the error rate. So if we have error in the API, then we will have here immediately an alarm that we can create. Another interesting part is the overview that we have with the APM. Here you see the whole overview of our application. We are going to select only Jenkins in this case. We will get a filtering only on Jenkins as we are interested about the service. We are going to select of 1 day because we want to catch also this problem that we have. Another view that we see here is the problem on the timeline, and here in this case there will be one of the this problem of this run of the pipeline. As I mentioned before, we can also go in deep dive. Is another run, and you see in this case the run was 1.86 second. We can also try to understand from a different run see if something changed. We can compare all of them, and this is also really interesting on observability. Our metrics, of course, they are not standalone. This will be used mainly for debugging, but Michele will tell us what we can do with AI.
Thanks, Francesco, for the observability preview. Now it's time to jump to the AI part. All of these metrics that you saw in Splunk observability that Francesco showed have also been integrated in Splunk IT Service Intelligence, which is what you're seeing here, and which we're using as our AI platform. So what you're seeing on this page is the service tree overview, which gives us insights on the structure of the CI/CD platform service. I suggest we look at a couple of these services just to get an idea. We have the Vault here, which is used for secret management. We got the Kubernetes cluster service mapped, which is, if you remember, we actually saw this in the CI/CD architecture slide. We've got also the GitLab CI/CD. However, this is out of scope for today's demo. And we finally get to our Jenkins CI/CD service node. If we look under it, we have two other nodes, which are Jenkins end-to-end and the Jenkins reliability service. If I click into one of these, I will see on the right-hand side, I will get a drill down will open with a list of KPIs related to this service. And if you look at these KPIs, you'll actually notice that these are some of the ones that we already saw when we were analyzing CI/CD, specifically when we were looking at its architecture. So we listed some of the KPIs. So for this demo, we implemented a few of these. So keep in mind that this data comes from the Splunk observability platform via the OpenTelemetry collector. And the idea is that all of these KPIs will contribute to the scoring that we see up here, which is currently 100, therefore healthy. So this was sort of a short overview of the service decomposition, but I suggest we move now to the actual AI part. So if I go here into the predictive analytics section, so this is, as I said, the predictive analytics feature, and I will use it to train a model based on my service and its KPIs. I will be using data from the last 14 days, and since what I want to predict is the service health, that is, whether it will be low, medium, or high, or critical, I will use the random forest regressor. So I will choose here, random forest regressor. The split is 70-30, which is fine, and I click on train. So this is now currently training the model based on my Jenkins reliability service, which I've selected, and its KPIs, and this might take a couple of minutes. Now we see that our model is ready. It has been trained, but also tested. Let's quickly look at the test results. Specifically, I want to see how my model performed on the test set. So if I scroll here to the bottom, I see different analysis, but what I'm really interested to see is the predicted average versus the predicted worst case health score. And we see that in both cases, it's 100%, which is okay. But if this were to go below, alerting and action would have to take place. This is something we also implemented, but for today's showcase, this is out of scope. I will save this model. And now I can finally use it on actual real data. So I again choose the Jenkins reliability service. Now it's loading the model for this service. I again select the random forest regressor. And basically now, while I'm waiting for the results, just to understand what I'm trying to calculate here is the service health score for the next 30 minutes. And this is the output that we get. And basically from this point on, the predictions runs automatically. Okay, let's summarize everything we learned so far today. We identified different challenges that come with CI/CD pipelines, and therefore concluded that we're talking about a critical platform that requires end-to-end monitoring. Talking about end-to-end monitoring, we also introduced the concept of observability, which is necessary in order to introduce full transparency and visibility across our entire infrastructure. In order to bring this data from our CI/CD platform into our observability platform, we made use of OpenTelemetry, an open source standard used to collect telemetry data and which is relevant in order to ensure reliability. Furthermore, we identified some relevant APIs that help us derive the state of our CI/CD platform. And finally, we applied AI to all this data in order to create some predictions and derive actionable insights. Why? Because our ultimate goal is failure prediction, which refers to the use of historical data in order to preempt failure before it actually occurs. And a final takeaway I would like to point out from today's session: start simple and scale fast. So perhaps you don't know where to start from. Well, maybe start from a simple experiment. See how the system reacts, see how it goes. And as you proceed, you can scale. You can basically build more and more on top of that. Well, it seems it's time to close the curtains. Thanks a lot for watching. I really hope you got something from this session. Until next time, cheers!